So here's a question from the JEE Advanced 2020 Physics Paper 2. And it says that a hot air balloon is carrying some passengers and a few sandbags of mass 1 kilogram each, so that its total mass is 480 kilograms. Its effective volume giving the balloon its buoyancy is V. The balloon is floating at an equilibrium height of 100 meters. When n number of sandbags are thrown out, the balloon rises. That's how usual balloons work. Rises to a new equilibrium height close to 150 meters, with its volume V remaining unchanged. If the variation of the density of air with height h from the ground is given by this function, this is an exponential decaying function, and where these are the constants, the value of n is. So this seems like an easy problem. Let's try doing it. So add the height of 100 meters. Firstly, you have, let's say you start out, so you're starting out with 480 kilograms. And after that, after you kick off some bags out of there, you get a height of 150 meters, and now your weight is actually 480 minus n kgs. Now, when is something balanced? Something is balanced at an equilibrium when the sum of forces on it, or the sum of torques acting on it, is 0. So there is no mention of torque around here, so we will just stick to forces. So at any height, if this is the object, if this has the volume V, and since V remains unchanged, we don't need to really worry about that bit. The buoyancy force that is exerted over this thing, let's say V is negligible in comparison to the variation of the density of air. If that is so, the force of buoyancy is equal to the volume of the air displaced, so that is V, multiplied by the density of the air displaced. So rho, I should draw rho like this, e to the power minus h by h naught. This is the mass of the air displaced, by the way, multiplied by g. Now, there can be a valid point in thinking about whether g changes or not, and yes, it does change. The gravitational acceleration, well, that does changes, but when you are at distances such as 100 meters or 150 meters, that's 0.1 kilometers. So it's not a huge change, so we neglect the changes in gravitational acceleration to make our lives easier. The second force acting on it is the weight of the thing. So that is the mass of the thing, mass of the balloon in this case, multiplied by g. Are there any other forces? No. So in order for this to be at equilibrium, the mass of the balloon should be equal to the mass of the air it displaced. So m is equal to V times rho naught e to the power of minus h by h naught. All right. Now what? So we put in these two situations, first at 100 meters and second at 150 meters. So at 100 meters, the mass is 480 is equal to V multiplied by rho naught e to the power of minus 100 by 6,000. And then we have 480 minus n is equal to rho naught e to the power of negative 150 divided by 6,000. Now, what do we do? So we don't know anything about V. So we can just divide these two equations. So we divide equation 2 by equation 1. So that gives us 1 minus n by 480. That is equal to e to the power of, notice these all get cancelled out. So negative 150 by 6,000 plus 100 by 6,000. So this is equal to negative 50 by 6,000, or negative 120. E to the power of negative 120, that is to say. So n is equal to 480 multiplied by 1 minus e to the power of minus 1 by 120. Now, calculators are not allowed on the JEE Advanced examination, so that's a bit of a problem. But what we can do is we can apply a bit of approximation. And that approximation is, it's a really well-known approximation, that e to the x can be for x's that are really close to 0. That is to say, you can approximately write this as 1 plus x. The infinite series expansion is actually 1 plus x squared upon 2 factorial plus x cubed upon 3 factorial plus x to the power 4 upon 4 factorial, but that just messes things up. And once you do this, you have e to the power of negative 1 divided by 120. This can be written as 1 minus 1 upon 120. And now you're subtracting this from 1. So you get 480 divided by 120. That's equal to 4. And actually, I should have taken n times the mass of one bag, so that would have been 1 kilogram. But anyways, the number of bags that we threw out in order to go to a higher height, that is equal to 4.